Hello, welcome all. Am I audible to all? Am I visible and audible properly? My voice is clear. Am my voice coming to you? Hello? Please reply in chat box. Good morning, good morning, good morning, Fatima. Yeah, okay. Very good, Fatima. Yes. Okay. So, yeah, good. Yeah. So its response is little bit late. So there might be some latency. Latency means when I am speaking and the voice is going to you and it is your response is coming back to me. That takes some time. That is called in physics latency. Every electronic system has some latency. Good morning, everyone. Good morning. Yeah. So let us start. In the previous class, we were discussing about basic maths. I have told you that physics will be covered in 3 parts, and I will be taking the third part of the physics. And in the third part, I have started with basic maths. All of the teachers in physics have started with basic maths. Okay. So in basic maths, why basic maths was needed? Because in physics, the language of physics, how we can explain the concepts, how concepts are written in form of equation, that required physics. The understanding of equation required physics. And without maths, the understanding of equation required maths, sorry. Without maths, we cannot understand the equation. Then how we can understand the physics properly? That's why the basic maths is required to understand the physics in a just manner. Okay, so that's why we all have started with maths first. Now, the part of the maths which I was taking was geometry. I have started with geometry part. So in geometry, I was covering some basic properties. How triangle, what is a triangle, how triangles are nomenclature of triangle is what. I have covered the exterior angle property part. The sum of the angle of triangle is 180 degrees. So I have covered some basic parts, basic concepts of the triangle. Let's proceed further. In the last part, I have covered the distance of centroid from the vertex of equilateral triangle. If this is an equilateral triangle, what is an equilateral triangle? Equilateral triangle is such a triangle in which all the side lengths are equal. All the side lengths are equal in an equilateral triangle. So if these side lengths are equal, this is called equilateral triangle. Sometime in questions, they give us charges are present at the vertex of equilateral triangle. Find the potential at the center. This kind of questions are asked. To find the potential here, we need this distance. So for equilateral triangle, if the side length of the triangle is A, the distance of centroid from any vertex is A by root 3. This concept was covered in the last class. Distance of centroid from vertex is A by root 3. Is this clear? Yes, sir. Okay, Ramya Goel. Okay, very good. Bahut badhiya. Very good. Now, if this concept is clear, so this is your first class. No, this is my second class, and I have been starting from basic concepts of maths. So I have been starting from class 7th at concept of maths. Okay, then from then onward, we will cover the basic concepts of maths, which is required in physics. And after all of these basic concepts, we will go to the physics. Okay, yeah. So the distance of centroid from vertex is A by root 3. The concept of equilateral triangle was also discussed. So we have covered the area of equilateral triangle. I have also covered the height of the triangle. Height of the equilateral triangle is A by root 3. This height comes out to be A by root 3. Root 3 A by 2, sorry. Root 3 A by 2. This distance is A by root 3. The height of equilateral triangle was root 3 A by 2. Okay. So let us discuss about some more properties of triangle. Now I will discuss about isosceles triangle. Isosceles triangle. What is the isosceles triangle? In isosceles triangle, two of the sides are equal. Suppose this is an isosceles triangle. This point is A, this point is B, this point is C. Then the meaning of isosceles triangle is two of the sides are equal length. So if the two sides, let's say AB and AC are of equal length, this triangle become isosceles triangle. We'll discuss some more properties of isosceles triangle. In isosceles triangle, the angles in front of the equal sides, these two angles are equal. If this angle is theta, this also comes out to be theta. This is the important property of isosceles triangle. In many questions, we will exploit this property. If there is an isosceles triangle, two of the angles are equal. Now, if these two are theta, you can also determine the other angle, remaining angle in the triangle. How you can determine this? Because sum of these three angles are 180. Sum of these three angles are 180. So 180 plus 180 minus 2 theta will be this. 180 minus 2 theta. This angle should be 180 minus 2 theta. That's why the that can only be the case for angle sum to be 180. So in an isosceles triangle, two of the side lengths are equal and the angles opposite to the equal sides are equal. Let us discuss one more property. If I drop a perpendicular from the top vertex, from the vertex where the two equal sides are meeting at the base, then this perpendicular, let's say foot of perpendicular is D, this foot of perpendicular bisects the base. This foot of perpendicular bisects the base. This is the property of equilateral triangle. If foot of perpendicular is drawn from the top vertex, then that D point bisects the base. This distance BD and this distance DC is equal. BD is equal to DC. BD is equal to DC. Okay. I am covering all of the basic properties which is already covered in the class 8, 9, 10. Okay. And these properties will help us to do question quickly. Whenever they are required again in question, I will again explain those. Okay. But first, we are covering all of the properties in first class itself. Okay. Now, these two distances are equal. Why these two are equal? I can explain this also. We can prove these two distances are equal. How? See that I am getting two triangles here, triangle ABD and triangle ADC. Can you see? There are two triangles here, triangle ABD and triangle ADC. Both of these triangles have one angle to be 90. Both of this triangle have one angle to be 90. In both of this triangle, here angle B is theta, here angle C is theta. And one side is common in this two triangle AD. So two angles are common or same and one side is same. These two sides are also same. Two sides and two angles are same. Hence, these two triangles are congruent. These two triangles are congruent. Triangle ABD is congruent to triangle ADC. These two are congruent. Why they are congruent? Because the angles are equal. Here theta, 90, 90, and these two angles will remain equal because if two angles are equal, then other should also be equal. Yes, dear Sharan, bilkul sahi. Okay. So these two angles are equal. This angle is also equal. One side is common. Two sides are common. That's why these two triangles are congruent. And this is how we write congruency. Okay. Triangle ABD is equal to triangle ADC. So this is the representation of congruency. Because they are congruent, all of the corresponding sides are now equal. So side BD should equal to side DC. This is the proof that side BD and DC are equal. Or we should say D point bisects BC. D point bisects BC. Okay. Note it down properly. See if there is any doubt. If you have any doubt, please ask. We are discussing about properties of isosceles triangle. Okay, we are discussing about properties of isosceles triangle. What is an isosceles triangle? An isosceles triangle has two of the sides of equal length. Okay, and when a perpendicular is dropped from the common vertex of the equal sides, from that the perpendicular on the base bisects the base. This is the property. Any doubt in this, or should I proceed? Is this clear? Okay, Ardhamenda. Okay, very good, very good. Sure. Okay. So properties of isosceles triangle is now covered. Okay. So what are the types of triangle? We will. Okay. We will use three types of triangle generally in physics. The triangles can be divided in three parts: scalene triangle, in which the side lengths are of unequal length; isosceles triangle, in which the two side lengths are equal, and if the three are equal, the triangle becomes equilateral. Okay. Now, so all of the properties which are required in physics, I have covered those. Sometimes the area of this isosceles triangle is also required. Sometimes very few questions are there in which this area will be required. So let us cover the area also of isosceles triangle. Area of isosceles triangle. Area of isosceles triangle. Area of any triangle can be determined using half base into height formula. Half base into height formula. Okay, half base into height. The base here, this length, can be determined using the side lengths which are equal. Suppose these equal side lengths are A. The sides which are equal have length A. So this base BD, because in front of 90, this is going to be hypotenuse. So this length can be written as base of this right angle triangle. And base comes out to be A cos theta, hypotenuse times cos theta. Whenever I have a right angle triangle in which hypotenuse is known to me, this angle is theta. The base of the right angle triangle can be written as hypotenuse times cos theta. The perpendicular of right angle triangle can be written as hypotenuse times sin theta. Hence, this length is A cos theta. BD and DC, they both are A cos theta. And this length AD, the height of triangle, this comes out to be A sin theta. AD is A sin theta, AD is A sin theta, A to D is A sin theta, B to C, the total base length will be double of this. Now, if we know this length, we can find out the area of the isosceles triangle. That will come out to be half the total base length, BD plus DC. BD plus BC will be double of this. 2 times A cos theta times height. And height is A sin theta. So if we just do a little bit of calculation here, 2 and 2 are getting cancelled out. A and A will be A square. So you will get A square sin theta times cos theta. This is area of isosceles triangle. When semi-perimeter is used to find the area, whenever the three sides are known, the triangle's three sides are known to us. Whenever the three sides is known to us, we will use the semi-perimeter type formula. Now, because one of the side length A is known to us, we can, in this question, we can use this formula half base into height, because height can be easily determined in this question. Okay, when this angle is given to us, height can be easily determined. Okay, so area of isosceles triangle. Yes. Thank you. Okay. Now, so we have covered area of equilateral triangle, area of isosceles triangle. So triangles, we have talked about a lot of things about triangle. Okay. So let's proceed to next types of figure. Next types of figure. After triangle, we will cover some basic few properties of quadrilateral. I will first start with a general quadrilateral. What is a quadrilateral? First, let us talk about what is a quadrilateral. Quadrilateral is a figure containing four sides, is a closed figure. Quadrilateral is a closed figure of four sides. Quadrilateral is a closed figure of four sides. Okay. And of course, you can observe here, there are four angles created by sides of the quadrilateral. There are four angles created by sides of the quadrilateral. Let's say this angle to be, let's say alpha, this is beta, this is gamma, this is delta. There are four angles inside quadrilateral. First of the property, you might be knowing this property, but it's my job to tell you about all of the properties. So alpha plus beta, just a minute. Yeah. Okay, alpha plus beta plus gamma plus delta. The sum of all the angle inside a quadrilateral is 360 degree, or we can write this as 2 pi radian. This is a basic property of quadrilateral that we will require. Okay. Yes, Likhat Raj. 360 degree. The sum of angles inside a quadrilateral, is 360 degree. So red color is not visible. Okay, let me change the color. This angle is gamma, this is beta, this is alpha, this is delta. You can take the angle in any order. The sum of these four angles inside quadrilateral is 360 degree. Can we prove this? Yes, we can prove this. Why we can prove this? Because a quadrilateral is just two triangles. If I draw a diagonal of this quadrilateral, if I draw a diagonal of this quadrilateral, this diagonal divide the quadrilateral in two triangles. Okay, this triangle is this quadrilateral is not divided in two triangles. This triangle will have sum of its angle to be 180. The bottom triangle will also have sum of its angle to be 180. So then if I add these two triangles, angles inside these two triangles, I will get 180 plus 180, 360 degree. Okay. Likhat Raj, you wanted to ask something. Please message this me personally, okay, or call us. Then we will discuss. Okay, yeah. So alpha, beta, gamma, and delta, the four triangles inside a quadrilateral, when they are sum up, the angle is 60 degree. The angle is 360 degree. Okay, so this is the basic property of quadrilateral. After the quadrilateral, let us move on to special cases of quadrilateral. So some special cases of quadrilateral is required in physics. I will first start with parallelogram. Parallelogram is we can say heart of vector. In vectors, there is a concept called law of parallelogram addition. Parallelogram law of vector addition. So parallelogram vector addition requires parallelogram. And a lot of concepts of parallelogram is then required in physics. Okay, so that's why we are starting. Sir, will you explain from starting an online class? Yeah, this is online class and all of the online classes recorded. So all things are now in your hand. You can just revise the concepts from the previous video lecture. Okay, and I am just starting with the very basic things. Yeah, parallelogram law of vector addition. Yes, that requires concepts of parallelogram. That's why I am starting with parallelogram. First of all, I will discuss what is a parallelogram. What is a parallelogram? A parallelogram is just a quadrilateral in which the opposite sides are parallel. We can write a parallelogram is a quadrilateral in which the opposite sides are parallel. These two sides are parallel to each other. These two sides are also parallel to each other. Okay. These two sides are parallel to each other. These two sides are parallel to each other. This class is on YouTube right now. Thereafter, this class will run in. This class was running from voice. Yes, Syed. Okay. A parallelogram has four sides. All the quadrilateral have four sides, and the opposite sides are parallel. If I name the parallelogram A, B, C, D, then the property of parallelogram is that AD and BC are parallel. AD is parallel to BC. This is the way of writing two sides are parallel. Okay, when I put a sign like this means these two sides are parallel, and AB is parallel to CD. AB is parallel to CD. Okay, so this is the basic property of parallelogram. Every parallelogram is said to be parallelogram only when the sides opposites are parallel. Now, if these sides are parallel, then with this idea, we know one more idea, that the opposite sides are of equal length. In a parallelogram, the opposite sides which are parallel, they are of equal length. Opposite sides are of equal length. Yes, Sriram, we will use that formula also. So AD is parallel to BC. These two are of equal length. AB is parallel to CD. These two are of also equal length. Opposite sides are of equal length in parallelogram. Now, sometimes we want area of parallelogram. In some question, area of parallelogram is required. Okay, because area of parallelogram sometimes gives us some important things like when you do cross product of two vector, the area of parallelogram is the magnitude of cross product. Okay, so how we can find the area of parallelogram? How we can find the area of parallelogram? See here, I have taken this angle to be theta. This angle to be theta. Okay, one more property of parallelogram I can cover right now. If this is theta, in front of theta, this also be theta. In parallelogram, opposite angles are equal. Opposite angles are equal. This is theta, then this is also theta. This is theta, then this is also theta. Okay, and these two angles are also equal. These two angles are also equal. And because sum of all this angle is 360, so this two must be 180 minus theta. 180 minus theta. 180 minus theta. Yes, because sum of all these four angles should be 360. So that is only possible when if these two are theta, then these two must be 180 minus theta. Okay, so this is the property regarding angles of parallelogram. Now let us find the area of parallelogram. For finding area of parallelogram, I will first find the height of parallelogram. Height, this length, this distance is called height. Okay, if I drop a perpendicular from B on the base, this is said to be the height of parallelogram. This length, the green color length, this is height of parallelogram. How I can find this height? H. See that this is a right angle triangle. This angle is 90 degree here. This angle is 90 degree here. In front of 90, this side length, that can be said to be hypotenuse. In front of 90, the side is called hypotenuse. In front of 90, this side is hypotenuse. And if this is theta, then in front of theta, this is perpendicular. This is perpendicular. Yes, so by concept of trigonometry, if hypotenuse is known to us, the angle theta is known to us. In front of angle theta, this is perpendicular, and that can be written as sine theta times hypotenuse. And the base of the triangle can be written as cos theta times hypotenuse. This has to be remembered by. Okay. Whenever you have a right angle triangle, hypotenuse times sine theta gives you perpendicular. Hypotenuse times cos theta gives you base. Hypotenuse times cos theta gives you base. Hypotenuse times sine theta gives you perpendicular. Length of perpendicular is sine theta. Length of base is cos theta. Okay. So now this hypotenuse, that should be equal to B into sine theta. Because this is perpendicular. In front of angle theta, the side is called perpendicular. In front of angle theta, the side is called perpendicular. Along the angle theta, the side is called base. The side along the theta angle is called base. And in front of 90, the side is called hypotenuse. Okay. So now the hypotenuse of this parallelogram is known to me. This is B sine theta. That is B sine theta. If the this height is now known to me. Now, if the height is known to me, I can find out the area of parallelogram. Let me draw the figure again here, because there are a lot of things in figure, so it's become cluttery. So let us draw a figure here. Now, this height is now known to me. I can divide the parallelogram in two triangles. I can divide the parallelogram in two triangles. See, I am getting a triangle here, and I am getting another triangle here. Okay, I am getting two triangles. This triangle, the yellow colored triangle, has a height of B sine theta, and the base length is A. Okay, the yellow colored triangle has a base length A and height of B sine theta. Similarly, if you observe here, let's say, let color this triangle to be in orange color. If you see this orange colored triangle, the height will be same, because these two are parallel line. These are parallel lines. So if this is B sine theta, this is also B sine theta. These are parallel lines. Okay, the parallel lines have equal distance. So if this is by B sine theta, this is also B sine theta. And this length was also A. See here. So now area of this triangle become half base into height. This triangle has an area of half base into height. This triangle also has the area same. The base of this triangle is also A, the height is also B sine theta. The height is same for both the triangle, the base length is same for both the triangle. Okay, this triangle is just upside down version of this sine triangle. They both are upside down version of this triangle. Okay, the base is H cos theta. No. See, this total length is base of this triangle. I am talking about this yellow color triangle. In this yellow color triangle, this length is base. Okay. If I wanted to ask you what is this distance, then that should be b cos theta. This distance was b cos theta, but I am now talking about this complete length. This complete length is a. Is this clear, Kadiri? Is this clear? Okay. So Kadiri, please reply whenever you get this doubt clear. Okay. Okay. I will explain this again. I am talking about this base. I am taking this yellow color triangle. This yellow color triangle has this length to be base. This is a. This is a. Okay. If this is a, this is b sin theta. The area of this triangle become half base into height. And area of this triangle also becomes same. So if I double this area, I will get total area of parallelogram. Total area of parallelogram. So 2 and 2 will get cancelled. That's why the area of parallelogram becomes AB sin theta. AB sin theta. Area of parallelogram becomes AB sin theta. Area of parallelogram becomes AB sin theta. Okay. Yes, AB sin theta. Very good. So whenever you have a parallelogram of side length A and B and the angle theta is between the sides A and B, the area of parallelogram becomes AB sin theta. Please write this properly. Please write this down. Area of parallelogram become AB sin theta. I will be requiring this concept in vectors. Okay. In vectors, AB sin theta is area of parallelogram. This concept has to be remembered. Okay. So some questions will become easy then. Yeah. So AB sin theta becomes area of parallelogram. So area of parallelogram has been covered now. There is one more property of parallelogram which we need to remember now. I will prove this property when we will learn about vectors. See, I am drawing a parallelogram again. I will tell you about one property. I will just give you the formula now and I will prove the formula in vectors. I will prove the formula in vector. A parallelogram has two diagonal. Every quadrilateral may be created by two diagonal. Every quadrilateral will have two diagonal. Here there are two diagonal are shown in yellow and orange color. Okay. If the base length is A, this side length is B, and the angle between A and B sides is theta, the length of this major diagonal, the diagonal which has larger length is called major diagonal. The length of major diagonal comes out to be A square plus B square plus 2AB cos theta. I will prove this formula in vectors. Okay, wait till then. Right now, just try to remember the formula. Just try to write down the formula. And length of the other diagonal becomes A square plus B square minus 2AB cos theta. Because we are learning about properties of parallelogram, so I thought it's better to give the property right now. And I will explain the property when we will learn about vectors. Okay. Just write down the property, just try to remember the formula. And after vector, you will surely remember the formula. Yeah. So properties of parallelogram now have been covered. These are the only properties of parallelogram which we will requiring frequently, and other properties may be covered in case-to-case basis. Whenever they are required, we will cover in those cases only. Okay. So what was a parallelogram? Parallelogram is a quadrilateral, has four sides. Two of these sides are parallel. Two of these sides are parallel. They are of equal length. Okay. So this becomes a parallelogram. And if the angle theta in parallelogram becomes 90, the angle theta becomes 90. What is the figure called? When the angle of parallelogram becomes 90, the angle between two adjacent sides become 90. What is this figure called? That figure is rectangle. If this is A, this is B. You must be knowing the area of rectangle. Area of rectangle is AB. Why this is AB? Because if you just put the 90-degree angle here, sin 90 becomes 1. We put theta to be 90. If this angle becomes 90, If this angle theta becomes 90, if this theta becomes 90, AB sin theta becomes only AB. Okay, so area of rectangle is now proved. Area of rectangle is AB. Okay, I should say verified, not proved, verified. Area of rectangle is verified. Okay, let's go to a spatial rectangle then, spatial quadrilateral or parallelogram then. See, in parallelogram, these two lengths were not necessarily equal. These lengths were different. But if in parallelogram, the two adjacent lengths become equal, that spatial figure is called rhombus. Rhombus, this spatial figure in which all of the sides are of equal length and opposite sides are parallel. This is a parallelogram, spatial parallelogram, rhombus. I'm not satisfied with my drawing, so I'm removing this drawing and I will again draw the rhombus. Yeah, it's a little better than last time. Okay, let's go with this drawing only. So rhombus. So if the sides of parallelogram are equal, then that figure is called rhombus. That figure is called rhombus. There are some special properties of rhombus. Again, this is a parallelogram. So all the properties of parallelogram will be property of rhombus. No, in square the angle is necessarily 90. Here the angle is not 90. Okay. Just sides are equal. There is a special property of rhombus. The two diagonals of rhombus are perpendicular to each other. The two diagonals of rhombus are perpendicular to each other. Please write this down. The two diagonals of rhombus are perpendicular to each other. The two diagonals of rhombus are perpendicular to each other. The two diagonals of rhombus are perpendicular to each other. All the sides are of equal length. All the sides are of equal length. Now let us talk about area of rhombus. Area of rhombus. Rhombus is just a special case of parallelogram. What was the area of parallelogram? What was the area of parallelogram? This was the parallelogram, and the area of parallelogram was here AB sin theta. AB sin theta. Okay, area of parallelogram was AB sin theta. Now the two lengths are equal. A and B are equal. So if I just put A and B to be equal, I will get A square sin theta. If this angle is theta, the angle between two adjacent sides is theta. The area of rhombus is A square sin theta. A square sin theta. Ramya Royal, sorry. This area is A square sin theta, not A square. A square sin theta. A square sin theta. When this is required? This is required in a question in electromagnetic induction. So all of the things which I am covering right now, they are somewhere required in physics. Okay. A square sin theta. A square sin theta. Okay, so this is area of rhombus. Area of rhombus is covered. Okay, and we can also write down some properties of rhombus using the properties of quadrilateral, like using property of parallelogram. Like if you put A and B to be equal here, you can find the length of the diagonals of rhombus. Just put A and B equal here, you will get the length of diagonal of rhombus. So that is not used frequently. That will be covered in vectors. So I'm not writing those things here. Just area is sufficient here. Okay, area properties needs to be remembered, and the two diagonals are perpendicular to each other. That is important. Okay, so rhombus is now covered. Okay, so let's proceed to the next figure. I have started with parallelogram, in which two adjacent, two in front sides in front of each other are parallel. Okay, and these two are also parallel. Now, if only two of the sides are parallel and other two are not, like this, these two sides are parallel and these two are not, the figure is called trapezium. The figure is called trapezium. Trapezium. The figure is called trapezium. Yes. PE, I think this is PE. Trapezium. Yes. Trapezium. The figure is called trapezium. Okay. Area of trapezium is required in many questions. In coordinate geometry, in vectors, in kinematics question. Sometimes they give you a figure in terms of trapezium. The area of trapezium is required. So how to calculate area of trapezium? In order to find its area, we must be knowing its height. This thing is called height of trapezium, and the length of the parallel sides. This side length is suppose A, this side length is suppose B. This side length is A, this side length is B. Okay, so this trapezium will have an area of half sum of parallel sides times height. Half sum of parallel sides times height. Area of trapezium is half sum of parallel sides into height. Area of trapezium is half sum of parallel side into height. You should also write this in words. Half of sum of parallel sides into height. Okay. So area of trapezium is half of sum of parallel side into height. How this formula is derived? You can also derive this formula on your own. You can derive this yourself. If you divide this trapezium into a rectangle like this is a rectangle. See that this is a rectangle. This is a triangle. And this is also a triangle. So trapezium is triangle plus rectangle plus triangle. Triangle plus rectangle plus triangle. If you add these three area, you will get area of rectangle, area of trapezium. Okay. So you can do this on yourself only. Yeah. Once you try to do it by yourself, if you are not getting this formula correctly, then I will try to help you. Okay, but that will be covered in some other class. Okay, right now the result is important. Proof is not important right now. Okay, so area of trapezium is also now covered. And what is trapezium? Trapezium is a special figure, a special quadrilateral in which two of the sides are parallel and two are not. This is trapezium. So quadrilaterals are covered now. Okay, so I have been covering the properties of geometry. I have started with triangle. After triangle, I have covered quadrilateral, some of the properties of quadrilateral, and some special quadrilaterals we have covered. We have covered parallelogram. This was parallelogram when two sides in front of each other are parallel, and rhombus, which is special case of parallelogram. And right now, just we have covered trapezium, in which only two sides are parallel and other two are not. Okay, so let's proceed to the next situations, next cases, next important concepts of geometry. Okay, so now we will start we have covered 4-sided figure. Now we will cover 5-sided, 6-sided, 7-sided, 8-sided figure. So, and only one thing is important for these figures: distance of center to vertex. So I will start with hexagon. I will take case of hexagon, and then I will generalize the special case of hexagon into general case. What is a hexagon? Regular hexagon. I am talking about regular hexagon. Hexagon is 6 sides. But when I'm saying that is a regular hexagon, I mean the 6 sides are of equal length. Okay. So a hexagon has 6 sides, and these side lengths are equal to each other. Hexagon has 6 sides and they are equal to each other. Assume this is hexagon. Drawing is not perfect here, so please assume this is hexagon. There is a center point of hexagon. There is a center point of hexagon. Sometime in electrostatic, they will give you charges placed at the vertices of hexagon, and they will ask what is the potential at the center. They will give you charges at the vertices of hexagon. They will ask what is the potential at the center. Or in gravitation chapter, they can again do the same thing. They put masses at the vertices. They will ask you what is the gravitational field at center, what is the total energy at the center, gravitational potential energy at the center. They will ask you this kind of things. For that, you will need this distance. the distance of center to vertex has to be determined. Okay, the distance, yeah, in gravitation, electrostatics, this kind of question usually we come across. So distance of center to vertex has to be determined. Okay, for that we will use some basic geometry. For that we will use some basic geometry and derive the formula. Okay, see, hexagon has 6 sides. Hexagon has 6 sides, and every side is creating some angle at the center. Every side is creating some angle at the center. See, every side is creating some angle at the center. Because this is a regular figure, so all these angles must be equal to each other, because this is a regular figure. Okay, okay, Queen, some girl named Queen is asking me something. Please ask this question later on. Okay, right now we are discussing this thing. Okay, so you can just call this to some administration person and they will help you out. Okay, sorry, I cannot help you right now. I should discuss this hexagon concept. Okay, so I have a hexagon here. Hexagon has 6 sides. These 6 sides are of equal length. Okay, and each side is creating same angle at the center. So angle at the center is created by equal by each side. Now what will be the total angle at the center? That should be angle of circle 360 degree. There are 6 sides. So each side will create an angle alpha at the center. That should be 360 degree by number of sides. Isn't it? 360 by number of sides. Okay, yeah, in special case of hexagon that is 60. But I am talking about general case. I will extend this concept to general case. Okay, that's why I am not putting value of n here. Number of side in the hexagon, that is 6. But right now I am putting that n here. N is 6 for hexagon. For pentagon, n will be 5. For pentagon, n will be 5. For septagon, n will be 7. For octagon, n will be 8. So for different shapes, different regular figures, I will put the value of n accordingly. Okay. So right now I am trying to derive a general formula for this distance of center to vertex. Okay. So first I had derived this angle alpha created by one of the side on the center. Is this clear? Now alpha angle is known to you or not? ये समझ में आया अर्धमेंदु? Okay, Durga Prasad is replying yes. Okay, very good. Yeah, thank you. Okay, so now this angle is known to me. So see, if the side length of this hexagon, or let's say regular polygon, is A, side length of the regular polygon, this side length is A. Okay, this distance has to be determined. That distance, let's say R, that distance is R. What is the distance? Distance of center to vertex. This has to be determined. R has to be determined. R needs to be determined. A is known to me. What I can do? I can use this angle alpha. To find out R. How? Let us draw the figure separately. Let us draw the figure here. Okay. So I will draw the figure separately. This was one of the side. This was the single side of the regular polygon. I want to derive this distance R. This distance center to vertex distance R. This has to be determined. R needs to be determined. What I will do? See that if I drop a perpendicular from the center on one of the side, this will bisect the side. If I drop a perpendicular from center to this side, this will bisect the side. What I am saying, this will bisect the side, because this is an isosceles triangle. We have discussed about isosceles triangle. In an isosceles triangle, a foot of perpendicular from top vertex at the bottom bisect the base. Okay, I have proved this, that these two lengths are equal. So the total base length was A. This was side length of regular polygon. This was A. So by bisection, this should become A by 2. This length is now known to you, A by 2. Yes, this length is A by 2. This is A by 2. This is A by 2. And the total angle here was alpha. So this half angle must be alpha by 2. If the total angle here was alpha, the half angle was alpha by 2. Isn't it? If total angle was alpha, half must be alpha by 2. Okay? Okay. Now, if this is alpha by 2, this is known to you, A by 2, this is R. See that this is a right angle triangle. Again, we are getting a right angle triangle here. In front of 90-degree angle, the side length is called hypotenuse. In front of 90, the side length is called hypotenuse. In front of angle, the side length is called perpendicular. In front of acute angle, this side will be called perpendicular. So A by 2, which is perpendicular, because A by 2 is in front of alpha by 2. This is acute angle. In front of acute angle, the side is called perpendicular. Perpendicular is A by 2. In front of 90, this is hypotenuse. Hypotenuse is R. So perpendicular by hypotenuse, that is sine of angle. Sine of alpha by 2. Sine of alpha by 2. Sine of alpha by 2. Isn't it? So R now can be determined. This is the relation between A and R. If you just cross multiply this, solve this a little bit, you can write A to be equal to 2R sine alpha by 2. This is A in terms of R, or you can use R equal to A by 2 sine alpha by 2. So whenever you want to find distance of center to any of the vertices, distance of center to any of the vertices. Someone is asking me a doubt. R value is A by 2. No, Royal. Ramya Royal. This is not A by 2. See, this distance was A by 2. Okay. See, we were discussing, we were deriving the distance of center to any vertex. Center to any vertex. So center to any vertex distance, I have termed this distance to be R. I was trying to find this R. For finding out this R, I was looking at this triangle separately. I was looking at this triangle separately. This triangle, in this triangle, the base length is A. So see here, the base length is A. I have drawn the triangle separately. This was the center. This was the center. And this distance R has to be determined. So I'm trying to find out this distance R. That R is derived using sine law in this triangle. Sine of alpha by 2 must be perpendicular by hypotenuse. So hypotenuse comes out to be this. Now, is this clear? And for any n-sided polygon, you can put the alpha to be 360 by n. Put alpha equal to 2 pi by n or 360 degree by n for n-sided regular polygon. Regular polygon. If you have hexagon, put n equal to 6. If you have pentagon, put n equal to 5. If you have septagon, just put n equal to 7. So if you have n-sided regular polygon, just put the value of n here, you will get alpha. You put the value of alpha here, you will get R. Is this clear? What we have derived? We have derived the center to vertex distance of n-sided regular polygon. The center to vertex distance of n-sided regular polygon. First, note it down. I will use this formula for hexagon, pentagon, septagon, and I will illustrate the use of this formula. First, write down the formula. Durga Prasad, no, R is not A. R is equal to A for special case of hexagon. Okay. In special case of hexagon, R is A. But in other cases, R is not A. R may be different thing. Now, so for for general case, we have derived the distance of center to vertex. Now let us use this formula for special cases. First we will solve for hexagon. What is a hexagon? Hexagon is 6 sides which are of equal length. Let's say this is our hexagon. Assume this is an hexagon. Okay. I want to find center to vertex distance of hexagon. This distance has to be determined. So how I can find this distance? Sir, can't we do the bisect side is root 3 by 2 and the base is a by 2 by Pythagoras theorem, finding R value? No dear, because I am talking about general case. I am talking about general case. Okay, I am not deriving this distance for special case of hexagon. Okay, I am deriving this distance for any general polygon. For general case of polygon, I will use this formula. Okay. In case of special case of hexagon, you are correct, but not in general case. In hexagon, if I want to find this distance R, this was A. The angle of one side at the center, that should be 360 degree by 6. So it becomes 60 degree. Now if I use the formula for R, that formula was A by 2 sine of alpha by 2. Angles half of this angle. Angle is 60 here and put half of that. This was the formula. Okay. So now this becomes A by 2 sine 60 by 2 is 30 and sine 30 is half. Sine 30 is half. Because sine 30 is half, so you will get A by 2 into half. So that is A. Okay. So in case of regular hexagon, this side length is also equal to A. This side length is also equal to A. And that can also be easily determined using the fact that this angle is 60. This angle is 60. These two are equal because this is an isosceles triangle. This length is R, this length is R. So this is an isosceles triangle. For isosceles triangle, these two are equal. If this is theta, this is also theta. And this is 60. So 2 theta plus 60 is equal to 180. This will give you theta is 60 degree. If these two are theta, 60, 60, then this becomes an equilateral triangle. So for equilateral triangle, all the sides must be of equal length. This is A, then this is A, this is A. Okay. So because in hexagon, this triangle becomes an equilateral triangle, we can easily determine the R. But for pentagon, for octagon, for septagon, we will need this formula. Okay. Some doubt is there? On Sunday, that will be informed to you separately. Okay. If you have any class, then that will be informed to you in groups. Yeah. So for hexagon, we have determined the center to vertex distance. Let us find center to vertex distance of pentagon. Pentagon. This is a regular pentagon in which there are 5 sides. This is a regular pentagon in which there are 5 sides. Suppose side length of pentagon is given to you. And you need to find distance of center from vertex. So what was the formula for this distance? In order to calculate this distance, we will first find out angle at the center. That angle was termed as alpha. Value of alpha was 360 degree by n. N for pentagon is 5. So this comes out to be 72 degree. Okay. For pentagon, this angle comes out to be 72 degree. Now, in order to find this distance, let's say this distance is R. So R was, the formula was A by 2 sine alpha by 2. A by 2 sine alpha by 2. A by 2 sine alpha by 2. A by 2 divided by sine alpha by 2. A by 2 sine alpha by 2. You can remember like this. A by 2 sine alpha by 2. So distance R become A by 2 sine half of the angle. Half of 72. What is half of 72? 36. What is half of 72? 36. So this comes out to be A by 2 sine of 36 degree. Can we determine sine 36? Yes. If we know sine 18 degree, we can determine sine 36. Or this is very close to sine 37. Because sine 37, we must be knowing the value of sine 37, that is 3/5. And 36 and 37 are very close angles. So we can, for approximate calculation, we can take this sine 36 as 3/5 for approximate calculation. Okay, not for exact calculation. And in many time in question, they will leave the sine 36 as it is. Clear? You can just leave the question here. You just put the value of r in this format only. Okay. Now, this is a separate thing. So I have derived the distance of center to vertex. Distance of center to vertex. Distance of center to vertex. I had derived the distance of center to vertex in case of n-sided regular polygon. And this is the formula for distance of center to vertex in case of n-sided regular polygon. Okay. So now we have covered some idea of n-sided regular polygon too. So I have covered triangle. I have started with triangle, quadrilateral, then special cases of n-sided regular polygon, distance of center to vertex. Okay. So enough of polygons. Let's go to circle. Now we will discuss some properties of circle. Some properties of circle. We are covering some geometrical properties. So in this, I am now covering some properties of circle. First of all, what is a circle? If anyone asks you what is a circle, how we will reply to him? How we will say what is circle? Can we just draw a figure like this and say this is a circle? No. Okay, we can not draw circle perfectly. So what is the special property of circle that is defined, that is defining circle? Can you give me the definition of circle or whatever you know about circle? Suppose your younger brother in class 8 is asking you, it's a closed figure. Someone is saying me it is a closed figure. Yes, it is a closed figure, but not all the closed figure are circle. So that is not complete definition. All parts are equal from center. Yes, you can just adjust this line to make it correct definition. Adjust this line, Vijay. Yes, Vijay, very good. Radius is same, bilkul sahi. Correct. So circle is a plane figure. First of all, circle is a plane figure. It's a plane figure. It's in a plane. Circle is a plane figure. Okay. Circle is a plane figure. What is circle? It's a plane figure. That means it is in a plane for which distance of all points from center is same. Center is such a point which is equidistant from every point on the circle. So this is the definition of circle. First of all, it is defined in a plane. Circle is always defined in a plane. Okay. Notion is saying me something, but notion that is not complete definition. Okay. That has a lot of loose ends. So in order to define something, your line or your language should be perfect. That is not perfect definition. Okay. Yeah. So circle is a figure in 2 dimension in a plane. It has to be defined that it is in plane. Otherwise, this becomes sphere. Okay. If you talk about any general figure in 3 dimension which is equidistant from a fixed point, that becomes a sphere. So to differentiate circle, we should write plane figure. Circle is a plane figure. It is such a figure which is equal distance. Every point on which is at equal distance from a fixed point, and that fixed point is called center of the circle. That fixed point is called center of the circle, and that distance is called radius. That distance is called radius. No, distance at that distance is called radius. This may be the definition of radius. Okay, so we are covering everything from scratch. I will assume as if you know nothing, and we will cover everything from basics. Okay, That's why no loophole will be in your preparation after the syllabus coverage. And if there are no loophole, you will definitely get very good rank. Okay, that's the motto here. That's why we are getting good ranks here. We will leave no loophole in your preparation. Okay, so if this is a circle, then distance of every point on circle from center is same. Distance of every point is same, and that distance is called radius. Okay, now let us define diameter of circle. What is the diameter of circle? Diameter of circle is double of radius, double of its radius. A line which is passing from center and cutting the circle. The distance between these two intersection point is called diameter. This length is called length of diameter. And this line segment is called diameter. This line segment is called diameter. The length of diameter is 2 times radius. Sometimes that is defined, that is written in terms of d. Small d or capital D, you can choose otherwise. You can choose either of them, small d or capital D. Someone chooses small d, someone uses capital D. Okay. Area of the circle, that is pi r square. In terms of diameter, that can be written as pi d square by 4. In terms of diameter, that is written as pi d square by 4. Area of circle, pi d square by 4, yeah, or pi r square. Pi r square. Pi r square. Circumference of circle, circumference, this total length, circumference, that comes out to be 2 pi r or pi into d, diameter into pi, 2 pi r. The length of circumference of circle is 2 pi r. The length of circumference of circle is 2 pi r. Okay. See one thing here, that length of circumference, let's say circumference is c, length of circumference is pi into d. So actually this was the case how pi was defined. This was the situation where pi first came into existence. Circumference of circles were observed to be proportional to diameter. Whenever we were trying a circle, whenever we were drawing a circle, we have seen that when the diameter of circle is large, the circumference was also large. It was observed that circumference of circle was proportional to diameter. So we have defined proportionality constant to be pi. This was the definition of pi. And the first way of determining pi was this, the ratio of circumference of circle to diameter. Okay. So this was something about pi, how pi came into existence. Pi is a number or ratio of circumference of circle to its diameter. Okay, the constant of proportionality of circumference to diameter. Circumference of circle was proportional to diameter. Proportional to diameter. And the proportionality constant was coming out to be pi. That constant was called pi. Okay, so now we have discussed something about circle. Let's proceed further. Now we will discuss about chord and secant of circle. Chord and secant of circle. See, if this is a circle, a line segment which is joining any 2 points on the circle, a line segment which is joining any 2 points on the circle is called chord of the circle. This is called chord of the circle. If I draw a line which is cutting the circle, see, this is a line which is cutting the circle. This is called secant. Secant. Secant of the circle. Secant is the line which cuts the circle. And portion of secant or segment of secant which is inside is called chord. What the difference between chord and secant? Secant is a line, chord is a line segment. The name itself suggests it is segment of line. Line has infinite length, but line segment has finite length. Is this clear? Is this clear? Line segment and secant. Okay, very good. So someone is asking something. Yeah, we can reach heaven if we, even if we are in hell. Okay, if we try hard enough, you should have you should have desire to reach in heaven. Okay, then you can reach everywhere. Okay, the word that I can't do anything, I can't do this thing, I can't do that thing, that shouldn't be in your dictionary. You should always be full of the confidence, then you can do anything. Okay. So some student was asking me that I think his or her motivation was when will he be able to select it in NEET. Yes, you can be selected. You just need to do hard work, enough hard work, and you should have desire to do that hard work. If you are reading but not having desire to read, then that reading is of no use. Okay. So just make your goal clear and just work hard for that goal. Don't think otherwise. Don't think any of the side things. Okay, just focus on one thing, your goal. Then definitely you can achieve anything. Okay, so this is a circle. If any 2 points on the circle are connected, if acha, okay. If any 2 points on the circle are connected, then that is called chord of the circle. Thank you, Noshin. If any 2 points on the circle are connected, that is called chord of the circle. If any line cuts the circle, then that is called secant. Okay. The line, the curve along the circle between 2 points on circle is called arc of the circle. This is called arc of the circle. And every arc creates some angle at the center. That angle, if you know the arc length and radius of circle, that angle can be determined. The angle at the center is equal to arc length by radius. This was the definition of angle in radian. This was the definition of angle in radian. So arc length can be determined using angle into radius. Angle into radius. This must have been covered in trigonometry also. Okay. Yeah. So let's proceed further. I have defined what is a chord. Now I will give you some basic properties of chord. Suppose this is a chord of a circle. It is at some distance from the center of circle. It is at some distance from the center of circle. If I drop a perpendicular from center of circle to the chord, this distance is called distance of the chord from the center. And this perpendicular divides the chord in half. This point divides the chord in half. Okay, this point divides this chord in half. Foot of perpendicular from center, foot of perpendicular from center, foot of perpendicular from center divides the chord in half. These two lengths are equal. These two lengths are equal. How these two lengths are equal? See, I will prove this. Let's say AB was the chord. AB was the chord. C is the center of circle. Let's say D is the foot of perpendicular. Let's say D is the foot of perpendicular. So this triangle ABC, this triangle ABC, okay, this is now an isosceles triangle. Why this is an isosceles triangle? Because CA is equal to CB. CA equal to CB. So this is an isosceles triangle, and that was the property of isosceles triangle. Then when a perpendicular is drawn from its vertex to the base, it bisects the base. So we are again using a property of isosceles triangle here, that D point is the midpoint of AB. So AD must be equal to DB. D is midpoint. Yeah, two sides are equal. These two sides are equal because these two sides are equal. These two sides are radius of the circle. The distance CB is equal to distance CA. They both are radius of circle. Okay. So if the total length of chord was L, this length should be L by 2. This length should be L by 2. Okay. Now length of chord, half of the length of chord, half of the length of chord, radius of circle, distance from center. They are creating a right angle triangle. See here. They are creating a right angle triangle here. So what property I can use here? I can use Pythagoras theorem. So by Pythagoras theorem PGT, I can write R square as D square plus L by 2 square. R square equal to D square plus L by 2 square. R square equal to D square plus L by 2 square. R square equal to D square plus L by 2 square. So this is a relation between the radius of circle, the length of the chord, and distance of chord from the center. This is the relation between distance of chord from center, radius of circle, and length of the chord. We will use this relationship whenever it is required. Okay. So I had derived a relationship between length of the chord, its distance from center, and radius of circle. One thing you can observe from here, radius of circle is constant. In a circle, I can choose different chords. For different chords, radius of circle won't change. If I am drawing different chords in circle, then it won't change the radius of circle. Radius of circle is constant thing for a particular circle. For a fixed circle, this is a constant. I can draw the chord at different lengths from the center, different distances from the center. I can draw chord near to center. I can draw chord away from the center. Okay, so this distance can be varied. If this is increased, that should be decreased in order to keep R to be constant. R square is sum of two things. If one of the thing is increased, other should be decreased. If this is decreased, length should be increased. It means when D is increased, the distance from center is increased, the chord becomes shorter. You can observe this also here. If I go away from the center, the chord is becoming shorter. If you go away from the center, you can observe here. Okay, the same observation is given by this equation. The distance from center is increased. The distance from center is increased. If you are increasing the distance, the length of chord is becoming shorter and shorter. And when the distance is zero, if the distance is zero, length of the chord become highest. The maximum length of the chord of circle is 2r. And that is the diameter of circle. This is the maximum length chord. Max length chord. The longest chord of a circle is its diameter. The longest chord of the circle. Longest chord of circle, its diameter. Sometimes this statement come in exam or some questions. The length of the longest chord of a circle is this. That means they are giving you the diameter of circle. Length of longest chord of a circle is diameter of circle. Length of longest chord of a circle, its diameter of circle. Okay. So I have covered some properties of chord here. One or two more properties are also required. Let's cover those. Suppose I have a chord of circle. Every chord of circle will create some angle at the center. Some angle will be created here. Some angle of chord will be created here. This is a chord. It is creating some angle at the center of circle. Let's say this angle is theta. I can also connect the ends of chord with the ends with points on circle. This angle sometimes need to be determined. This angle sometimes need to be determined, or this angle is given, then this needs to be determined. There is a relationship between these two angles. This angle at the circle is half of the angle created at the center. Is half of the angle created at the center. A chord creates half angle at the circle, then it creates the angle at the center. If a chord is creating angle theta at the center, this is center, then it will create half angle at the circle. This is a special property of chord. Okay, so let me give you an example. If in a circle a chord is creating some angle at the center, let's say this angle is 120 degree. Okay, if one asks you what is this angle, then that must be equal to 60 degree, half of this, theta by 2. The angle of chord at the center is double the angle that is created at the circle. Please note this property. This property is exploited in some questions in circular motion. I will also use this property in a special case of potential at the corner of the disk. Potential at the corner of the disk. So this property is very useful in some tricky questions. Okay. Whenever these properties are required, again we will again explain these properties. We will again prove these properties and use this property. But right now I am gathering all of the properties that we are requiring, and I am giving all of the property right now. Yes. Okay. Last property which may be required. See that if a diameter is drawn in the circle, the angle that diameter creates on the circle is always 90 degree. On each point on circle, if you connect the ends of diameter, this is 90. Anywhere on the circle, if you connect anywhere on the circle to the ends of diameter, you will get 90 degree angle for any point. This point also, if you connect the ends of diameter to these points, this angle will be 90. Whenever the diameter of circle, the end points of diameter are connected with circle, the angle is 90 degree. The angle of diameter of circle on the circle is 90. The angle of diameter of circle on the circle is 90. The angle of diameter of circle on the circle is 90. Write this down. Sir, in the before property, how come length changes? We are considering it from midpoint. No, in the previous case, this chord may be any random chord. Maybe any random chord. Any random chord, if it creates some angle at the center, it will create half of the angle at the circle. Not this. Okay. In the previous case, this case. So you can change the distance from the center. You can draw chord away and away from the center. If you are going away from the center, the length of the chord reduces. I was saying here, this length of the chord reduces if you increases the distance d from the center of the circle. If you go away from the center, these chords are getting shorter and shorter in length. Is this clear? Ramya? Okay, yeah, very good. So let's proceed further. So this is the last property which I have discussed right now. Any diameter of circle creates 90 degree angle on the circle. Any diameter of circle creates 90 degree angle anywhere, 90 degree angle on the circle. Is this clear? Okay. So we have covered some basic properties of geometry for triangle, quadrilateral, circle. Okay, and I have also covered the distance of center of an n-sided regular polygon from one of its vertices. Okay, and whenever these properties are required in some question, we will again prove these properties or again define this property, and before using, we will give these properties to you. Okay, now I have tried to cover all of the properties of geometry which are required frequently. Now, from next class onward, we will start some basic coordinate geometry. We will first cover some basic coordinate geometry, then we will cover graphs. Okay, so graphs and basic coordinate geometry is the next topic for the next class. Okay, I hope everything is clear in today's class. And if you have any doubt, you can again revise because this lecture is on YouTube. So you can again watch this lecture. Thank you. Thank you. Last property, yeah, if you want, I can repeat the last property. A diameter of circle is here. Any diameter of circle creates 90 degree angle on the circle. Any diameter of circle, let me draw the diagram again. Any diameter of the circle, this is the diameter of circle passing from center. It will create 90 degree angle on the circle. Diameter of circle creates 90 degree angle on the circle. Okay? Okay. So because time is over now, so I should stop now. Thank you, everyone. Bye, everyone. Let's meet in next class. Thank you.